and welcome to synthetic division. So this is a problem like with the ones that you're going to be doing where you're going to have a larger polynomial divided by a smaller polynomial. Now, in order to do synthetic division, this smaller polynomial, the binomial here, has to be of the form x plus or minus some number. It can't be x squared. It only will work if that's a single x plus or minus the number that's right here, okay? So all of the problems we're going to do are going to look like that, but in general, you have to have your second polynomial look like this. So just a quick aside here, what I want to do is just look at a regular division problem and think about what it actually means, okay? So in regular division, so let's take something really simple like 6 divided by 2. You do 6 divided by 2, and everybody knows that that's 3. Right? And so if you wanted to check your work, if you wanted to make sure that you were right, you could take what you were dividing by, okay, this number right here, that's after the division sign, and the answer that you get, and you could multiply it together and see if you get the original thing that you were dividing, okay? So if we do 2 times 3, that does indeed give us 6, so we know that we did this problem right. All right, so we're going to kind of use that to check our work over here because it's not obvious that we're actually dividing as such, okay? So if you remember synthetic evaluation from before, the first thing that you always do is you draw your noodle lumpus. Yay, noodle lumpus. All right, and so then what you're going to do from that point is you're going to look at the polynomial that is being divided, okay? So that first polynomial, and you're going to use that, you're going to use the coefficients from that to write across the top here, all right? So that's like the polynomial that they were having you evaluate, all right? So x squared has a coefficient of 1, 9x, coefficient of x, and then the negative 22 over here, all right? And then what you're going to put on the outside is you're going to look at what you're dividing by, and you're going to look at the actual number. So this is negative 2, and you need to divide by the opposite, and that's what everybody always forgets to do. People want to just take that number right there. Nope, you got to take the opposite of it. So since there's a negative 2 here, we are going to use a positive 2. All right, so now real quick, we're just going to do our noodle lumpus work here. So bring down the 1. You multiply 2 times 1 to get 2. You add 9 plus 2 to get 11. You multiply 2 times 11 to get 22, and then negative 22 plus 22 equals 0. If that was a little fast for you, then go ahead back to the synthetic evaluation video, and I explain in more detail there how to do that actual part of it. Okay, so now we need to get our answer from this bottom row down here. So how that works is we're going to look at the original polynomial that we have, and we're going to say, what's the largest exponent? So the largest exponent here is this positive 2 right here, right? And so we're going to go 1 lower than that. So 1 exponent lower than that, which in our case is going to be just a regular x, okay? If it was x to the 10th, we would start with x to the 9th, okay? So you're always going to just go with whatever is 1 kind of step below the largest exponent, okay? So we're going to start with just x, and we're just going to read from left to right across the bottom row, and that's going to give us our answer. We're just going to go down like we do with polynomials, just 1 exponent at a time, all right? So we have 1x, and then after that you just have the number, so plus 11, okay? So we just read across there, and then the last number here is going to be the remainder. I'm going to do another problem where it's not 0, but the easier problems here have a remainder of 0. All right, so if you get a 0 here, you don't need to do anything else. Here's your answer. And if you wanted to check that, you would multiply out, we can do that real quick, our x plus 11 times what we divided by up here, just like we checked to see that that worked. All right, so you would multiply by x minus 2, distribute, x times x is x squared, x times negative 2 is 2x, negative 2x. 11 times x is 11x, 11 times minus 2 is negative 22, so plus 11x minus 22, and when you combine like terms, you get back to the polynomial you wanted, where you have x squared plus 9x minus 22. So we know that our answer is right, because when we multiplied our answer times what we divided by, we got what we were dividing. All right, and that's it.